In this video, we're going to look at adding fractions. The key part when we're adding fractions is we must have the same denominator. In other words, we must have the same number on the bottom of each fraction. Basically, the process for doing this is that we're going to add the numerators, but we're going to keep the denominators. So, we're going to take, in this case, 2. We notice that they have the same denominator, so we're going to take 2 plus 1, which then would give us 3. And we're going to keep the denominator of 5. The reason why we go about doing this is if we think about our model, or think about pizza, for example. We have a pizza, and let's say it's broken up into 5 slices. Okay. Out of the pie, the first person might get 2 out of the 5 slices, or the second person might just get 1 out of the 5 slices. Well, how many slices of pizza in total are eaten? So if we think about a pie with 5 slices, once again, we have the first person eating 2, and we have our second person eating 1, which means in total 3 out of the 5 slices have been eaten. 3 out of the 5 parts are whole. We have not changed how many pieces or how many slices the pie is broken up into. We just say how many pieces in total, in this case 3 out of the 5, are actually being eaten. So this is a fairly simple example of what happens once we get the same denominator, which is key when we're adding the fractions, because think about it in terms of the pieces of the pie. What happens if they're not the same? Well, let's take the model of the problem 1/2 plus 1/3. In this case, at first, half of a pie might get eaten, and then 1/3 of a pie would get eaten. So how much in total? Well, if we take the first half and we move it over to represent our answer, we take the second, or the 1/3, the second person eaten, and we're going to go ahead and rotate this. So we're going to slide it right into our pie right here, very roughly at least. Okay. What this will show us is it's kind of hard to tell. We have 1/2 and we have 1/3, but we don't have anything in common to say this is the slices that they had eaten. So we're going to need to take our pie and we're going to need to divide it up a little further. Okay, we can't talking in terms of a half because that's not fully occupied. So we're going to need to divide these up and we can't divide them up into thirds either, so we're actually going to need to divide it up into 1/6. And then I can look and say, well, 5/6 of a pie was eaten. But how do I know that? Well, I can take the 1/2, convert it to an equivalent fraction, in this case 3/6. I can take the 1/3, change that into 6 as well, put 6 slices on that. So I'm going to add, in this case, 2/6 to give me my total of 5/6. Once again, once I have the same denominators, I'm able to just change the numerators so that 1/2 will equal 3/6, 1/3 will equal 2/6, 3 plus 2 gives me my 5. And once again, I keep my denominator the same. So this is nice, and this works fairly well, but this is only part of. We don't want to have to draw the models every time. Plus, it's hard to draw them very accurately. So let's go ahead. Whoops. I'm going to go ahead and just start with a new page. So let's take the same problem, and I like to work them out vertically, just so I have a little bit more room to work. If I take the 1/2 plus 1/3, and I want to know that what that's equal to. What I need to do is take the 1/2 and 1/3 and think which fraction would be equivalent to 1/2 and 1/3 with the same denominator. So basically what I'm looking for is what is the least common multiple of 2 and 3. So if I think about the multiples of 2, 2, 4, 6, 8, so on and so forth. And if I think about the multiples of 3, 3, 6, 9, so on and so forth, 6 is going to be the first multiple I have in common. So that's going to be my denominator. A lot of times the denominator will be given just by multiplying 2 by 3. Okay, or the two denominators together to get a common denominator down here. It won't necessarily always be the least, but at least it would be something that you're going to work with. If you get the least common multiple, the least common number that they have in common, you're going to save some reducing at the end. But anyway, 1/2 then, if I think about what I know about equivalent fractions, I would have to multiply it by 3 to get to 6. So 1 times 3 would be 3, or 1/2 is equal to 3/6. 3 times 2 would give me 6, so 1 times 2 would give me 2. When I'm finding the equivalent fraction, I need to make sure that whatever I do to the denominator, I also need to do to the numerator. I've got to be fair to that fraction. So if I multiply the denominator by 3, I also need to multiply the numerator by 3. Denominator by 2, the numerator by 2. So once I have found the same denominator, I can just take the numerators, add them together, and I get 5/6, which is what I saw modeled by the example on the previous page. So another example, what's 2/3 plus 7/8? Well, I don't want to have to draw this out, so let's talk about our newfound way. 2/3 plus 7/8. If I think about what's the least common multiple of 3 and 8, well, 3 times 8 is 24, and in this case that is going to be the least common multiple. So I put a 24 on the bottom, and then I think 3 times 8 is 24, 2 times 8 would give me 16. 8 times 3 is 24, so 7 times 3 is 21. I'm going to go ahead and add these two together, and I get 37/24. Okay, now I need to look at this, and I need to notice that my numerator is larger than my denominator. This is called an improper fraction. We need to change this to a proper fraction, or a mixed number, before we're done. So 37 goes into 24 one time, and then I will have 13/24 left over. So what this is basically telling me is if I'm looking to fill up pies, I can put 24 slices here, and if I think about what 37 minus 24 is, I get 13. So I'm going to have 13 out of a possible 24 left here. This is a 24 out of 24, which is basically going to be one whole pizza plus 13 slices out of 24 left for the second pie. So that's going to be my answer. Okay. And this problem brings up a good point. In order for an answer to be completely correct, I have to remember that my answer must be given as a mixed number, and it must be fully simplified or reduced. So an example of this might be if I end up with an answer 14/8, I might change that into 1 and then I have 6 out of 8 left over. So for the 14, I take 8 away to make 1 whole, and then 14 minus 8 gives me 6 over 8. Okay. This fraction, 6/8, is not fully reduced yet, because 6 and 8 are both divisible by 2, which would give me 1 3/4. This would be the fully correct answer. So while this is equivalent, in math it's not considered fully correct because it has not been fully simplified, which here in 6th grade means changing it to a mixed number and then also reducing it. I hope this has been helpful, and we're going to take a look at subtracting fractions next, and then we're going to move on to how to work with mixed numbers.